Hello. Today I wanted to add yet another feature to the game because the map, let me move the task. The map is essentially done, although we will revisit it later. But the level stitcher is a complex task and I need one more thing to implement before properly begin to think about the way we will stitch levels together. And it's an additional feature. Let me show you. In the game so far we have levels, and the main puzzle is to reach the exit, and we cannot exit until we make the shape the sigil is indicating. So in this case we make the shape with the boxes or the rocks, and we can collect the sigil and exit, and we will have tunnels or tubes or something that will transport to other levels, etc. But I wanted to add another thing for the player to do, and to collect other things like ore or jewels or precious metal or something. So I wanted to make an auxiliary map of the level to indicate all the possible positions the player can reach. For example, I'm not sure in this case if this position I'm signaling is reachable. So I want the generator that already calculates something like that for the possible doors to mark all the positions that are reachable for the player, and put something there. For example, if we could reach this space, we could put here or here or here. We could put precious metals, or in the space to put something to collect. I think I will put it in the walls because it's cuter that way. Okay, so I will need in the generator, let me see. Here I have the level map where I store the spaces, the doors, and the lava. We have the crate map. By the way, this is an optimization I made the other day. I did not show it in a video because it was a bit boring to do, but I achieved some performance from it. Okay, we have the level map, the crate map, and I want to do the collectible map. I don't know if do it with this one. No, because I want to store more information. We need, for example, let's call it ore map, and we will store in the int that it contains. Let's see, in the level map we store a 0 if the space is empty, it is a wall, a 1 if it's a space, a 2 if it's a door, and a 3 if it's a lava wall. And in the crate map we store the index of the crate that occupies that position in the crate list. In the OR map, we will store we will store the difficulty of reaching each position. By default, it will be 0, indicating that the position is not reachable, or a positive number, indicating the minimal number of steps needed to reach it. So, in the find solutions function, let me see. We are this code calculates the potential solutions. This only if we are not holding anything. Let me see. Yeah. Or collect or. It's funny that door and or rhyme. Let's do yeah. Let's do yeah, update our map. Let's make a function for this. Okay. Each time we are not holding anything, we will need to check. Yeah. Okay. We will need some of this space. Let me see. Yeah. We will need something like this, but for the OR map. This should be called at, not in, but never mind. Okay. OR map. Let's see. And we need a function that sets, yeah, like this for the OR. Let's move this here. OR map steps. Let's yeah, set steps at this is not necessary. This is I'm using a fixed radius for the map because I know that I'm not generating anything that exceeds this size, obviously, but and because the fixed size arrays in the D language are faster, so I only do fixed size maps, but this could change in the future. I don't know. Okay, this is steps. Okay, Then we have a function to check the map. Yeah, this returns it. And one function to set the value. Okay. Let's see. Then if if we already reach that position, it already contains the minimal numbers of steps to reach it, because I should explain a bit about the find solutions. The find solutions function performs a breadth first search of the position. So each time we reach a position, or let's say it like this, the first time the function checks a position will be the shortest solution, or the shortest set of sequence of steps to reach it. So if the map already contains a value greater than 0, we return. And if not, we set, we need a parameter here. Let's see, we have the father is a position. We calculate a solution here. Interesting. We are not storing. Okay. This will be a bit. This will make it slower, I think. Although I don't know if I use, because we in the dictionary we store a state with a string and a parent. Okay, we should perhaps this should be yeah, we should make other let's use directly a string hash, or yeah, and we could have here a state. No, sorry, the state struct is useful, but instead of instead of storing the move, we will store the steps, all the solution, and we don't need the parent. Why? Let me see. Explore position. It's a list of hashes. No, sorry. This needs a state and the steps to reach. Yeah, and we will use it in a different manner. This will store the string, the complete string, and this will be positions. This will be its string, the empty string. We will not need this function. and we will have the state with the initial position and the empty string. Yeah, initial position. Okay, so obviously this will not compile because of many things. 247. What's this? Ah, this is a const function. No, sorry. Yeah, the dangers of copy pasting. Although when you have a typed language, it's much easier to fix certain things. So 1936. Obviously, this is a state, and we will need the state, and we will need the steps here. Let's see. We use, yeah. Now this is okay. This function is yeah, okay. Let me see. 1936 of type byte state. Ah, sorry. This is a hash. This is 1937 steps to reach. Sorry. And 1963. Yeah, obviously. Explore. Okay. We have the steps. We will need we will need this. We will need this. This is all. State to string, yeah. All this for to have the steps. Yeah, we need length. This will be an unsigned long. Let's see, we still have to fix some things. Yeah, the list. Here. State of current hash steps. Okay. Now we have, obviously, perhaps this will let's see first if we generate the same levels that the reference implementation. Okay. Files test level small and reference level small are identical. I should show this. We have two reference levels files with different sizes for different purposes. We have in this file the reference level small file. We have a bunch of levels we once upon a time generated and I use it to check in the profile script. We make a profile version of the game and we generate some levels. We store them in a temporary file and we compute the difference with a reference file. This I do this to check for each big change, like the change I just did, that implements a new feature, or in this case I did not change really the generator yet because the output is the same, and that's precisely what I want to check, that when I do some optimization or when I do a restructuring or refactoring of the generator to ensure that the output is the same. So in those occasions we use always the same random. We have this check here, and if we are not calling because in these cases we call the generator with a parameter that tells the generator to generate, in this case, to generate only 100 levels or 100 solutions, and the generator detects that and uses always, in that case, uses always the same random seed. I think I already explained this, but it's never too much. Okay, so in this case we are confident that this change that I just did to the generator did not break anything, or if it broke something, it broke it in a way that is very magical. So we will do a timing. Yeah, we will make a check of the timing. Let me pause the... Okay, it's already finished. Effectively, it's a bit slower than before, but not for much, a pair of seconds. Yeah, we are generating 92 solutions per second, and the output is identical, so we are confident. Okay, let's return to the update or map function. Okay, we now have the steps. So we need the position. We set it. Yeah, this will make it a bit slower, but okay, now we have this information. Now let's print this could be interesting to show. Each time we generate a level, we could print yeah, we will print the This obviously will change the output, but okay. Let's map size. No. For map XY and a tab character. Okay. No, sorry. This we need to return this string. Let's use this code here. Okay. Obviously, what's this? Update or map. Yeah, this is const. Long. Yeah, unsigned long. How do we don't need the this no, it's this function. No, let's use an int and let's make a class here. Okay. Now, test level small. Wow. Interesting. Let's add a new line here. Okay. We are spaces. Okay. We have information about the. This is interesting. Of course. This is very interesting. Let's load this level. Let's use this level. Let's use this level as the first level in the game. This is very ugly, but I wanted to check. Let's see. Let's load the level 0. Okay, we have always the same level. It's interesting. Why is the... This is weird. Why is the... yeah, it's let me see. Using tabs 3. Why is not... Okay, I don't know what happened here, but okay. We are using, let's see, let's remove this from this. Let's remove this. We are, yeah. Size, okay. Let's see, yeah. Now the format is correct, Okay, now we have this information in the levels, and we have the game here. Okay, let's see. We have positions that are reachable. Let's deduce where are this is okay, we could mark in some way. It's difficult to think. These zeros are surely they are walls. 1, 2, 3. There should be a 3 here. We are, yeah, never mind. This is this is funny because in the, yeah, here we must use, yeah, we need half the value because of the way the solution strings are computed. We add the character indicating the movement and a number indicating the number of crates that are moving. So in this case, for example, we have the solution indicates a down movement, moving 1 crate, then an up movement, moving 1 crate, etc. So let's recompile. Yeah. Also I changed a bit the, yeah. Let me show you. In case of a door, we print an equal sign, and in case of a negative value, we print only the minus sign, so it's clearer in the map. Okay, let's see. We see interesting things. Yeah, for example, the 0 here is the initial position because it's reachable in 0 steps. This position is a 1 because we reach in 1 step. The same with this one, etc. We cannot reach this one because if we reach it, we die. So it's a negative value. Okay, this is interesting. See, this position is reachable in 6 steps. 1, 2, 3, 4, 5, 6. But this one and this one are much more longer because we must move this crate to reach those positions. And I think, let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11. Okay. Yeah, interesting. We already have interesting differences between more or less trivially reachable positions like this one and this one. Yeah, this will be interesting. Okay, for now I think it's a good point to stop. Tomorrow we will continue selecting which positions are more interesting to use, because it's not only the easier way is to choose the highest number, but it's not always the best criterion. So okay, for now we will end the video here. Thanks for watching. If you want to support me, there are some links below to do so. Share the video with your friends or with people that could find this kind of things interesting. Thanks.